quicker than on some part of it. Thank you for having me. And yes, I will ask Aaron maybe to talk a little bit about what they're doing as well along the way. But mostly that would be me. So really, I presented to the group a bit more than a year ago on the topic and where we were at in respect of research and on calcined clay, and I wanted to give you an update. So I will talk about very quickly about the research, the full-scale trial that happened in the past year and the perspective of calcined clay. So hopefully everyone know what calcined clay is. So basically clay alone, you need to activate it, and usually you use thermal activation between 650 and 800. And you've got a beautiful plant there on the picture. That is the one, a recent one that was from Heidelberg Material in Ghana. That's a flash calcination method. And what happened is like, we use, at least 50% less energy in order to produce the calcined clay in respect of like the thermal energy, because we are calcining at much lower temperature. And there's different methods that you can use, the rotary kiln and flash calcination. This technology, as Aaron mentioned, it's actually well known internationally, and it's used and applied internationally. And it has been used on a lot of different structure. But here in Australia, we didn't have suppliers. That can actually allow us to use it on project very recently. So the application of calcined clay, we can use it in a very wide range. So from very low substitution in order to maybe improve durability and other different things between 5 to 30, or in much wider proportion, either alone or in combination with other SEMs, or fully substitute the cement and use as a kind of geopolymer based or alkali activated based material. So it can cover the whole range. These heaps of standards that included calcined clay internationally. I put here the list. There's a lot of like concrete standard and cement standard in Europe, and some also in US that all include calcined clay and metakaolin as a whole, and they've got formulation and accept that in their code. Today, us in Australia, we only have for now the material on the material qualification on the ES 3582.4 that is at since 2022, where you can get your material qualified under this this umbrella. But we don't have it in the cement standard, either in the concrete standard. Why it's interesting, it's because the raw material, we've got a heap of it in Australia, and we've got good clays. So there is different clays. Some are reacting quicker at lower temperature, etc., better than others. We've got a lot of area in Australia where we can have, where there is actually good clay, and it can support the sustainable concrete technology for quite a while in our future. And so that's why a lot of people are coming around and starting working on the topic. There is not only the feedstock of calcined clay is not only on mining. We can also recycle clays from a lot of different avenues. You've got waste clay from different operation, refractory brick or other operation. You can also recycle the excavated soil. You can have byproduct from quarries, decontaminated soil and sludge, etc. So all of those are actually rich in clay and proven either in the literature or even in full-scale application that we can do something with it. Then it's maybe more a matter of how we put that around in the standard and how we introduce in those different sources and how we put that in bracket in order to be sure that we can work with it on concrete application. Maybe Aaron, you can, if you can jump here and just talk about your the material that you have. I know in the past James presented the product that they have at Geotech. So if you can tell a little bit about what is your material about. You're on mute. Aaron, you're on mute.
Apologies. I hope now everyone can hear me. It's not
Yes.
the fault. So we produce a traditional clay set of products from Dulux, Visi, Norsk, Boyer, Sellies, Bostik, Yates, Estee Lauder, Body Shop. They're traditional markets, like paper, adhesive coatings, pharmaceuticals, clay, cosmetics. But in doing so, what we worked out was, yes, you can produce a very good grade 1 we've done as a primary product, but over the years we bought a going concern from Emerus. It had about 50 years worth of tailings in settlement ponds and tailings dams that were there. So we wanted to see if we could utilise those sort of byproducts to produce a lower embodied carbon sort of, clay. So we have been successful in some work we've done with Rackel at Melbourne Uni in creating a grade 1 sort of SEM there with that kaolinite. But I think more broadly, it's a very good material. The kaolinites are just decomposed granite systems. They're all around Australia. So as an answer to as a more broader approach and an answer to as a national sort of solution, it's a very good one. As Rackel said, it's understood. It can span the gamut of using it as a replacement. Potentially a finer product could be a silica fume replacement, all the way down to some of the soils, clays that are in soils that perhaps not as good as a kaolinite or a pure kaolinite, but still nonetheless would fit the bill. So as a general overall, I think that it's the products that we've got out of Victoria are probably ready to start to go into production within the next sort of month, 2, 3. We could be ready to go. So yeah, I think it's it'd be good to be involved in trying to bringing in these new SEMs. And getting the industry sort of here, at least in Australia, sort of used to using them.
Thank you, Aaron. On this point, I just wanted to compare why we are spending some time on that. It's also, we are not sure about how much slag we're gonna be left in the next 10 years. Fly ash, we don't know. I mean, we know it's gonna close at some stage. We don't have enough information on the recycled fly ash and etc. at the moment. So I just put here a comparison on the different embodied carbon, where that is calcined clay. All of that is from EPDs and international and EPDs and national EPDs in order to compare where is calcined clay compared to the others. So you can see the range is quite wide. Is around the one that we've got for slag, still above the one that we've got for fly ash at the moment. It depends how you calculate fly ash anyway. I just want to show you one of the full-scale calcination that happened in the past year on one of the clay that we selected as high potential, and we've been able to produce enough material in order to push it to full-scale trial, because it was one of the constraints, and what I talked about before a year ago, it was like we were really struggling to have enough material to move on the technology to more structural application and have an understanding, at least at this scale. So that happened in the last year. So that's one of the processes that can be used. There's other processes that can be used. I just put several pictures here of the clay. And here I like this picture because we've got a whole range of clay and a whole range of colors. So it's something that we have to work with potentially when we want to produce concrete with it and see how it's going to go. And what I wanted to share with you is really that we've got grade 1 clay already available, grade 2 clay that actually demonstrated really good performance for concrete depending on the application. So I think we are blessed in Australia, and we've got a lot of there's a lot of potential there. There is a heap of research that has been done. I just put you here some numbers like publication on Australian clay. I'm not talking about publication of people who use actually clay from overseas. I'm talking about clay from Australia that has been calcined and has been studied by our researchers. Here are all the universities working, and why there is a QR code at the top there, it's because there is the Australian Clay Advancement Network. And if you want to participate to that, and if I forgot you on the list, which I'm sure I might have, and if you want to participate to this network on the Calcined Clay Advancement, just click on this QR code and you will be part of the mailing list and on the activity that we are running on this topic. So a lot of people are starting or working on it and trying to develop our knowledge and our confidence on the topic. Very, very brief overview. It's there is some word to mouth saying like it's workability, it's hard, and it's possible depending of the fineness of the clay that you're going to have some challenge in respect of workability. You can see on the picture there that we were quite happy with the slump, even the slump after 1 hour, we were still having 160. So they are like real data because we use this concrete on trial. So it can be overcome. It can be challenging, but it can be overcome with the chemicals that we have at the moment. Mechanical performance, we never actually had any issue on that. Early edge performance in precast, very early demolding can also be achieved, but again, it depends of what clay and what precaution you are using and the system that you are using. Respect of durability, we knock everything over, like most of the performance that I've actually measured, but also that has been reported in respect of durability. We've got a very good result with calcined clay-based concrete. The only one that is always remaining and is always the same case with any ACM is the carbonation resistance. And I can have hours of discussion around how we are measuring that if you want to. I just wanted to show you what we've done. So that's picture of our third trial. We actually, what happened in the last year, we've been able to push it to larger scale, which was a very big step because a lot of things are happening in the lab, and the fact that we've been able to calcine in bigger quantity and prove that actually we can put that in the field was very important to push this step forward. So in Victoria, we've been able to have the pre-approval on one of the formulation that we've developed, and we've been able to pour on permanent project. And you've got a bunch of name at the bottom here because without a collaborative effort, or that wouldn't happen from the lab to the field. So I give you here a timeline more or less from early October to very recently. We've been pouring full-scale calcined clay in different concentration, different formulation from, I believe, 20% up to like 65% cement substitution in blends. So and they've been all of them has been quite successful. So that's the first one. I've got a few pictures of there here with some with what it looks like when we're pouring the concrete and how it was placed and what it looks like after. That was in October last year, and it was a very successful pour. Our second pour, the concrete was a little bit wet, and we had very bad weather condition on this day, so we had some shallow cracking on the top, unfortunately, and the curing wasn't done properly. However, the concrete was sound. We've done the remediation, and we moved forward from there, and being more cautious on the trial. And I've got some key information for you thereafter. Third trial was great. Also, on the same formulation, we've been able to pump, and we got very good workability and placement, etc. What was very interesting and what I wanted to talk about is as soon as you push it at full scale, we've got a lot of takeaway and a lot of things that should be taken into account in order to appreciate. And when you push a sustainable concrete on site, there's several things that should be done also in parallel, and I'm going to come back to that. And one of them is to be able to have a reference on the side on the same day, etc., in order to mitigate whatever the behavior. Instead of blaming the material, if you've got a business as usual on the side, then you can actually make the comparison. On this day, we also the advantage of doing a full-scale pour, especially for a researcher like me, is to pack up on all the samples that you can cast at once and get as much information as possible. So here you can see we had a hot box. We also cast bending, flexion, fatigue, creep, corrosion, permeability, chloride, and carbonation samples at the same time on the same mix in order to start capitalizing on durability full-scale try kind of data and be able to move on to potentially structural applications. So it is really an effort that we need to keep in mind when you get the opportunity to pour at full scale. These projects are a little bit different. So this one, that's not the same clay. They are both clays that we recycled fully from the project Northeast Link that we calcined. So there's two different clays. You got one that is very brownish concrete and the other one really gray. And both of them has been poured at full scale on the project. And those one have high replacement. We only have 35% of cement in those kind of mix here. But once again, what is very, I didn't remember that I had a video. I'm going to cut that. But out of those trials, what is very important is like, especially for us researchers, when you move, and for also, of course, the engineers and whoever who are here and participating and helping to support such technology, it's to be there on site and record everything and have the monitoring and detectors in order to be able to follow the behavior, not only on the day, but afterwards as well. We had, most of the time when you bring a new material, they don't have any silos, they don't have anything in order to be able to put it on. But with that silo, we found some ways to actually be able to pour at full scale, even though we don't have any silos. Making sure that you can pour with ease, it's very important. So your formulation needs to be really adjusted in order to allow pumping. And once again, here you can see make the most of the full scale application. So hot box, a whole bunch of cylinders and testing and stuff like that for you to get all the dots aligned and bring up the confidence in the technology. And also pour on side the business as usual and your concrete and see how it goes. It's really, really important to try to do that in order to because as the second trial we had horrible condition and so then start blaming the material instead of have an overview of actually how a business as usual concrete would work. I want to a big shout out of the collaborative work. I don't think you can input sustainable concrete on full scale if you don't have all the different parties and all those different very important points that are happening, like having transparent communication, a huge planning, sharing the resources and a risk mitigation. And that happens only if you've got collaboration between all the different parties involved. Finally, I just shout out on the network who are working on calcined clay. We created that a while ago. There is a lot of different working group. And if you just scan the QR code and participate to our activities, I can involve you in the different working groups that are interested in this technology. And hopefully I'm not too long and I can answer your question.
No, that's really good and really interesting as well. So that was great to see like the data, I guess, on the embodied carbon or the